So to start, these are the three rules that we're going to be going through and talking about. And then, like I said, like we started doing with chain rule already, I'm going to throw ease in there and trig and all that stuff. So we'll do product rule with that, and then we'll do quotient rule and with that. And then these start combining, so you can get problems that are really, we just try to do chain and product. Chain and quotient is a giant pain, so we try to avoid that. Usually we can. But these two will be combined in talk. So that's like where we're headed. So we did this. We're doing this today and maybe tomorrow. Like we'll see how it goes, and then we're doing quotient. But I think it'd be a good idea for you guys to just write all three of those down like in the same spot in your notes. And today we're worried about the product rule. So this is when you have a function with an x in it times another function with an x in it. You can't just take the derivative of each one and multiply them. It doesn't work. So I'm just going to write product rule on the notes here, but you guys, I would recommend writing all three. So what I will say all the time is 2d1 plus 1d2. What I mean by that is the second thing. I'll wait till you're done writing. I just told you to write it and then start yapping. Is that why you're looking at me? Took the day off yesterday. Just to get a haircut, yeah. No, my daughter was
just so
sick.
you don't have to come and observe the SATs.
And I don't really like that, but that's not. My daughter was sick. But then I got to school this morning and Mr. Gill was like, "You missed the last 3 assessment days." Didn't realize that, sorry. That wasn't the reason, but I can see why you would think that.
I mean, if you got breaks, can't you?
I mean,
break on?
3 is probably getting a little, like, I better be at the next one.
I mean, if you have vacation days, can't you legally take?
Yeah, like I couldn't get fired or anything, but I mean, it puts an extra burden on Mr. Gill because he has everything planned out, and then, at 3 a.m. I emailed him, I was like, I'm not going to make it. So, what? Who? What are you talking about?
SAT day, just skip it.
Oh.
I'm saying.
Just skip
It's like
Abby, what happened to your car?
my car. Oh.
Yeah.
So I had to take it in like a week after we got it for 3 weeks because apparently there was something wrong with the tire, and so I had to take it back again because there's something wrong with my steering wheel.
That's not even what I was asking.
How
Wasn't it
did
like
we get
missing
to
the other day?
Because my parents took it to the shop without telling me.
Oh.
And then they took their cars, and I was stuck with nothing.
Oh, okay.
It was just that simple.
That's not it. That's nowhere near as interesting as I was hoping.
I told them I said,
You went in, beat the robber up, and
Yeah.
No, but not. You literally.
Okay. So, with product rule, so what I'll say all the time, like when I'm going through them, like when I say chain rule, I don't say this. I'm like, take the derivative of the big guy, leave the little guy alone, derivative of the big guy. So my like expression, or what I'll say over and over again for product rule is 2d1 plus 1d2. So what I mean by that, as I erase the d, is, this is a disaster. So what I mean by that is you write down the second thing, and you multiply by the derivative of the first thing. So d1 is the derivative of the first thing. And then 1d2 is write down the first thing, derivative of the second thing. So you might be thinking in your head, you might have learned this a different way, I don't know, but the order doesn't really matter, right? It's addition. So could you do 1d2 plus 2d1? Yes. The reason I teach it this way is because quotient rule is that ordered also, and it's subtraction. And now the order matters. So to me, it's easiest just to remember the 2d1 and then 1d2 because that pattern fits for product and quotient. But if you decide to do this the other way around, it's not wrong. subtraction they were gonna use. So 2d1 plus 1d2. So the hard part of these is not the product rule. It gets hard when you start combining stuff like trig and ease and all that. And then what you have to do with these is get your answer, if you can, into one term. So that's one of the hard parts that we'll look at as we're going. Let's just start with an example, simple ones. So let's say like x squared plus 4 times e to the 3x. I guess that's not super simple. And then the next one, I should have started with this, but I want to show you like why it works too. I want to prove it to you that it actually works. But I'll do that after this. So the product rule would say, okay, this is your 1 and this is your 2. So you have a function of x being multiplied by another function of x. You cannot just take the derivative of this one times the derivative of this one. It doesn't work, and I'll prove that to you in a second. So what you're going to do is the second thing, so f prime of x is rewrite the second thing, the second function, so e to the 3x. Multiply by the derivative of the first thing, so what's the derivative of x squared plus 4? 2x. Plus the first thing times the derivative of the second thing. So now we have a chain rule in the mix here. So I'm already combining product and chain. So when I do the derivative of the second thing, what's the derivative of e to the 3x? E to the 3x times 3. And that's the product rule. Like, we're done with that. What they would want you to do, or what I want you to do from here, is to get this into one term, because eventually we're going to get to, okay, find a horizontal tangent line, or find relative max and relative min, which is what we're going to start doing like next unit. But to do all those, you set your derivative equal to 0. So if I'm going to set it equal to 0, I can't set this equal to 0 easily. I want it in one term so I can have, like if I have x plus 2, e to the x times x plus 2 times x minus 4 equals 0, there's that, it's called the zero product property, where you can take each thing and set it equal to 0, and this would be like x equals 4, x equals negative 2. What would this be? When does e to the x equal 0? Never, so this just wouldn't happen. But that's where we're headed. So we're going to get into one term with chunks, and then we want to be able to set each of those chunks equal to 0. So what I would do here is look for things I can factor out. So common terms or common chunks between that and that. So what's in common that I could like reverse distribute and pull out in front? E to the 3x. So if I take an e to the 3x and put it out in front, you're doing distributive property backwards here. So what you're essentially doing is dividing both of those terms by e to the 3x. So when I do that, what's left in the first term is 2x. And what's left in the second term is x squared plus 4 times 3. You guys see what I'm doing there? Factoring out that e to the 3x? So if you were to distribute this now, you'd end up where you started, right? So like, what's e to the 3x times 2x? You get that. And what's e to the 3x times this stuff? You get that. And then I would simplify the inside. So this would be like 2x plus 3x squared plus 12. And so now if I had to set it equal to 0, it's already set up for me to do so. So I could set this piece equal to 0, this piece equal to 0, and go ahead and solve from there. So that's usually how they will simplify them. That's how I want you to simplify them for the gateway or for your homework or for whatever. Does that process make sense? Did you guys do product rule last year? Did you get to it in pre-con? No? Okay, doesn't matter. Let me prove to you that it works. So let's say we had y equals x squared plus 3 times 4x minus 4. Bless you. So to be honest, I probably wouldn't use product rule for this. Your job is just take the derivative. So you can simplify it, you can use product rule. There's options on a lot of these. What I would probably do here is distribute, like just FOIL it, and then take the derivative one term at a time. So I'm going to do that. And then I'm going to do it So if I distributed and FOILed and all that, so FOIL would be 4x to the third, so first, outside would be negative x squared, inside would be 12x, last would be negative 3. I just drew a picture of Jarvis. Eyebrows, nose, mouth. And then if I took the derivative, it'd be 12x squared. What'd you say?
I just looked at him and I said,
So do you agree with me that that's the derivative?
yeah.
So this is a failed attempt at the derivative because people will forget product rule and they'll just go, oh, I'm going to take the derivative of the first piece and multiply it by the derivative of the second piece. Do I get the same thing? Do I get what I'm supposed to? I do not. So product rule is not an option. Like it's not a technique that if two things are being multiplied together, you either make it so they're not being multiplied together or you use product rule. You can't just do the derivative of the first times the derivative of the second. Garbage.
Now you drew a picture of me.
That's a picture of you.
Oh, he's right. Oh.
So if I were doing the problem with product rule, I better get the same answer, right? Or product rule is stupid. So, second thing, 4x minus 1 times the derivative of the first thing, which is 2x. So this is like my 2 and my d1 plus 1 times d2. What's the derivative of the second thing? It's 4, right? You guys with me on the product rule piece there? You see what I'm doing? And then if we distribute and expand and combine things here, we better get the same thing. So 2x times 4x is 8x squared minus 2x plus, then distribute here, 4x squared plus 12. And then if I just combine the x squareds, I end up with 12x squared minus 2x plus 12, which is what I got before. So I'm just trying to convince you product rule works. If I gave you that problem, I don't care how you do it. If it's easier for you to use product rule, use product rule. If it's easier for you to distribute it and FOIL so there's not a product anymore, you can do that. There are choices on a lot of these, but you cannot take the derivative of the first thing, take the derivative of the second thing, and multiply them together. That will never work. All right. Questions on that? Did that convince you it works?
Yes, it does.
Try this one. So a lot of problems on the worksheet today that I give you, you don't need the product rule, but I want you to do it anyways because I want you to practice it. Yes. Am I supposed to like get up and walk over?
It doesn't look like.
Who is it? Is there someone even there?
I just think
Yes.
Come in. Oh. Hey. Do you need to pass? Do you need to- Okay. Yeah, no, thank you. I told him not. Like, why so bad? That's my fault. Why did you raise your hand?
I was putting it down. I said, yeah. I didn't. I was not. My brain wasn't processing.
Gotcha. All right. But please ask your question if I don't talk about it. Cece, you're gonna get yeeted in a second. You don't turn around and pay attention. I can't see what that says. C over C gets yeeted. See, do you understand what I did there? Okay. So, first thing, second thing. So, 2d1 plus 1d2. So the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. That's the product rule. That's the calculus. Questions on that piece right there?
No.
So then your job is to try to factor or reverse distribute, however you want to say it, so you get down to one term. So what could I take out of both of those terms? A little more than an x. I can take a 4x. So if you took a 2x or you took an x, after you factored, you would be able to do another factor. And like do it again until you get to the full factored version. So then essentially you're dividing both of these by 4x. So that would leave me with sine of x times 2 plus x times cosine of x on the inside. And that's not easily solved, and that's kind of still a mess, but it's the best we can do. So if I set this equal to 0, this part's easy to solve. This part would be a mess. But how many had that? Or understand how to get to it? Or did I address your question?
Kind of. Why would we keep the sine x? Like, why would we keep the x on sine and the x on cosine when we're taking an x out? Does that make sense?
Yeah, because x by itself and x being sine or cosine are two different things. Like if I took an x away from the sine of x, what would be left?
Yeah.
It would just be sine, like sine of what? You know what I mean? So you can't really.
But if it's sine of x squared, do we take it out?
No, because that's still different. Something that's being signed. So you're saying if I had like sine of x squared plus x squared,
Yeah.
could I remove an x squared?
Yeah.
No. You can only take things that aren't being signed or e'd or ln or
Okay.
whatever. Yeah.
Okay, one question. Is there any difference between brackets and parens?
Brackets and what?
Parens, parentheses.
Parens? Is
Yes.
that the coding way to say parentheses? No.
That's what I was thinking.
No, you're good. No, I just, like, for me, it's easier for me to see it if it's in brackets, especially when I get, like, multiples, but then you're fine.
Okay.
You might get to a spot where there's, like, 3 or 4 sets, and it's easier to organize, but that's up to you. Alright. I did too, it just took me a second. Do that one, and I understand you don't have to use product rule for this, but please do.
Quite different.
Is it really? I mean, I was making them up, so. That's pretty darn close.
No, it's very different.
than chain rule? Well, that's because I haven't put really a bunch of trig and e's in there yet. You don't want me to prepare you for the AP test?
I don't know.
Let me think about it. Alright, so there's your first thing, there's your second thing. They are being multiplied, so it's a function of x times a function of x. You have to either multiply it out, so there's no product rule necessary, or use product rule. I'm telling you, I want you to use product rule just so you practice. So second thing is 3x minus 1 times the derivative of the first thing is 2x plus 4. This is my second, this is my d1. Plus the first thing times the derivative of the second thing. So this is my 1 times d2. This is even, like, I would never use product rule in this problem. But because I'm trying to practice it, that's a different story. But because I have to FOIL anyways, I'd rather have just FOILed up here and just gotten it over with. But I'm going to have to FOIL now. So this is 6x squared plus 12x minus, is that a minus 1? Yeah. Minus 2x minus 4, and then distribute this 3, so 3x squared plus 12x. So if we combine all of that, we have 9x squared minus 2x minus 4. Oh, that's a positive 12x plus 22x
Minus 4.
minus 4. Yeah,
Yeah.
I was canceling I canceled those. That doesn't work. 9x squared plus 22x minus 4. How many had that? Everybody except me. Cool. Alright. Alright, let's look at those tables. So remember like the chain rule tables we did? You're at data table. I'm the stupid one. Not you. Try that. So h of x is f times g, so do your product rule. And then plug 4 in to this table, grab your numbers and see what you want. I haven't taught it yet, I understand that, but try it. I'll go through it and we'll try a couple more. In the meantime, I have to pee. nothing today. Just talking. Absolutely
And
nothing.
then she's yelling at us like, why do you have to write it down? It's not hard.
Alright, so I gave you h of x, but h of x is a product. It's two functions of x being multiplied together, so you have to use product rule. So the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. So that's literally this right here that we had written down before. And then I'm just plugging in. So h prime of 4 is going to be g of 4 times f prime of 4
Times f of 4.
plus f of 4 times g prime of 4. So g of 4 is 3, f prime of 4 is 2, f of 4 is 3, g prime of 4 is 1, 6 plus 3. Am I at 9?
Actually, don't raise your hand.
We write this down.
I heard her say actually. I was like, this is.
Do that. Same thing. We're just practicing again. Do the problem on the board.
Oh, that is it.
Oh, sorry. You can just.
You don't say it out loud. Stop spoiling it.
No, this is why no one likes
Like, honest to God.
I think you can do it in your head. Just.
So practicing.
I'm sorry, I'm
You just yelled at someone for giving away the answer.
Yeah, very the answer.
Josh, I'm pretty sure I didn't say anything. Oh my gosh.
I just can't believe how many times everything you say brings you up to be Oh, okay.
Guys, I got the answer.
Proud of you.
Alright, 5 please. So I'm going to shortcut it a little bit here. So this is going to be, g times f prime plus f times g prime, and we're plugging in 3. Did you guys realize we're plugging in 3 and not 4? Okay. You get the same answer. Are you serious? Oh yeah, so it'd be 0 times, -2. So, yeah. So make sure you plug in the right number, because apparently it doesn't matter in this problem, but obviously it will sometimes. So g is 1, f prime is 0, plus f is 4, times -1/2, so you end up with -2. And you would get the same thing here, you'd have -4 plus 2, which is also -2. Wonder if that... No, they don't all do that. How many are -2? Okay. So today's the worksheet's a little weird because, like I said, you probably wouldn't use product rule to do any of those problems. But you're going to need product rule for things down the road, obviously. So try to do them with product rule practice. Tomorrow we'll do quotient rule. It'll be similar. Like a lot of this is kind of like not necessary for these problems I'm going to give you tomorrow, but will be down the road. So we're trying to learn like the foundation before I start building the house. That was a smart thing I said. And then again, you have a crap ton of con, right? But this is another thing. So product rule you didn't know before, now you do. So there's some more of the con that you are able to do now that you couldn't before.